Hello everyone, my name is Ahnaf and welcome back to my YouTube channel. It has been a while since I've been active on YouTube, and as you can see I've also lost my ability to speak in front of a microphone. The last video uploaded was on August 28th, 2 years ago in 2023, and now I'm kind of back with a new video. So this is going to be a devlog for my latest project, which is an end-to-end encrypted instant messaging platform. I have been, away from developing things because of academics, which was also the reason why I kind of disappeared on YouTube. But now that my exams are almost over and I'm back, I'm planning on starting off with a project that will be challenging. So I also want to record my journey throughout the entire project and also discuss the technical implementation and all of the other things related to this, so I can basically just have like a series of videos that is going to be from the start to the end of the project until we can get a usable version. And of course the project is going to be open source on GitHub, so you guys can check out the source code. If anybody wants to contribute, if anybody wants to help out, you guys are welcome to do so. So let's just kind of get started with the features that the project is going to have, or at least it should have, because at the end of the day, it all depends on whether I can implement them or not, or whether I have the time to implement them or not. But yeah, the first thing, as I've said before, this thing should have end-to-end encryption. That means all of the messages going from one client to another client, and it's definitely going to go through a network, it's going to go through the server, going to go through the system, it's going to get stored in the database. It has to be encrypted so that nobody in the middle of the request, in the middle of the network, can snoop in and steal the messages or read the content. So the main idea for this is to have security, and on the server side I do want to go for a zero knowledge architecture. So the server is not going to know what you're writing, but it's not going to be fully zero knowledge, because of course the server will know who you're writing it to, but it's not going to store any raw user credentials first of all, because even credentials, when you're first registering an account, the passwords, they will not be sent in a raw form. The hashing for the password is going to be done on the client side using web crypto and other libraries like Lipsodium. And then the hashes and salt search is going to be sent to the server. And for those, I'm using Argon 2 because it's memory heavy, and it's not going to be that really easy to crack, and it's also going to be protected from rainbow table attacks. So yeah, I mean, that's kind of the basic features. Oh, another thing I forgot to mention is all of the sensitive data is encrypted on the client side. Nothing leaves the client or goes through the network or to the server, you know, unencrypted, okay? Because the system assumes, or at least I assume as the developer, that the entire network or the communication channel is insecure. There will be man in the middle attacks. I don't trust HTTPS. So all of the stuff is going to happen on the client side. So the client side will require a lot of work for all of the cryptographic functions and everything. But of course, libraries do exist, so I'm going to be using those. And the credentials on the server, which are stored in the database, for example, user passwords and also encryption keys and everything for messages, these are all stored encrypted, okay? You don't store the raw encryption keys on the database because, again, what if the database gets leaked? So yeah, these are the basic features. Okay, so enough said, let's talk about the architecture of the project. And this is a really simple diagram because I'm not going overboard with, the complexity and everything. This is really simple. I'm just trying to make sure that, okay, I design it a way that it's scalable, but I'm not gonna, prematurely optimize it or just go overboard with the entire thing. And yeah, I'm not going to do that. So if we take a look at this diagram, you can see that the application containers are going to be, of course, deployed with something like Docker, and the application, the main server backend, is going to be written in Golang. And the reason I chose Golang is because, number one, I love Go. Okay, Go is an amazing programming language and I just love it, and the mascot is cute. Secondly, for real-time applications like this, Go is just, it's the real deal, okay? It is made for this kind of stuff with its concurrency model and the simplicity of Golang as a language and also its channel systems. It is just really good for making stuff like this. So that is why I'm using Golang. And another architectural point that I want to mention is that I'm not separating the WebSocket uh, part and the REST API part into like two different services. No, this is a monolithic application. Okay, I don't need to go microservices from day one. Try to keep it as simple as possible, because the more complicated you make it, the more pain you're gonna have later on. Yeah, I don't like pain. So I'm gonna have both the REST API and the WebSocket endpoint on the same application. And later on, if required, I can separate it, but I don't really think I would need to do that by now. Um, on the right side, if you pay attention, we have a NATS cluster, and I did mention in my previous video that what NATS is. I kind of gave uh, an example, a technical example of how it works, and I'm going to be using this for inter-node communication. So if somebody sends a message on, let's say, node 1 on the WebSocket or REST API application, now all of the other users connected to the different nodes do need to somehow receive the messages. And the application containers are not aware of each other, of course. I'm trying to make them stateless. So the NATS cluster will act as a central message broker, and it will dispatch the messages or the events to every single node. So if some guy on, let's say, node 1 sends a message, it's gonna go to the NATS cluster, and then every single node in the application container cluster, or the set of containers, will be subscribed to the NATS cluster, and it will receive those messages. So it doesn't matter on which node the user is connected to. If you send a message to your friend John, and it doesn't matter what server John is connected to, he will receive the message. And yeah, so that's basically why I'm using NATS. And NATS is also really scalable. You can just deploy a NATS cluster with however many nodes or brokers you need, and just make everyone just connect to it. It's really simple to use, really simple to set up and performant. When it comes to databases, I chose PostgreSQL because number one, I like denormalized databases, but then again, you have to take this into consideration that I cannot have both the message data and also the application data, which includes user information or the conversation lists or inbox lists, like okay, which conversation or group chats the user is a part of. This kind of application information and the message information should be separated, because the message database will get like a huge amount of write requests. Okay, if this thing scales and we get to, like, let's say, I don't even know, like 100,000 users, or maybe just say 10,000 users to start with, the amount of load I'm gonna get on the message database because of the number of messages that's gonna be sent per second is gonna be absolutely insane. Which is why I'm separating the two databases into a message database and an application database. That way, I can scale the message database whenever I need to, right? If I need to add more Postgres nodes, more shards, I can do that. And the application database, most of it's going to be read heavy, because you're just going to pull the user information and the list of conversations. There's not going to be much writing to this database. It's only going to happen whenever someone sends creates a new inbox, or maybe just creates a new account. That's what's going to happen. So, and I can also deploy a caching layer on top of it. I can just have something like Redis for caching the user information. So the application database is not going to get much load. So I'm keeping this separate because I assume I will not need to scale this much. So this is an overall view of the entire thing. And of course, in front of the entire application, I have the load balancer. Now, if I deploy it on the cloud, I'm definitely going to use something like a cloud load balancer. Or if I deploy it like, from scratch, maybe just on a bunch of VPSs, I could just use like Nginx, and with a service mesh like HashiCorp console, or maybe Invenio, which is a small service mesh I made. Okay, I am unable to talk. I'm sorry, guys. I'm sorry. But yeah, I can just put a load balancer, and I'm not gonna include sticky sessions, okay? Because if I enable sticky sessions, what's gonna happen is that if a client makes a request to server one, and then he makes another request, it's gonna get redirected to server one. I do not want that, okay? I want the application to be as stateless as possible. So maybe on the first request, the load balancer sends it to server one. The next request may go to server 10, and it doesn't matter which server it goes to, the application should behave the same way every single time. Because when you're developing applications like this and you're doing this on scale, it is really painful to have stateful applications deployed on scale. Okay, so yeah, that's that. And for the front end, I'm just gonna have like a web browser. I'm not really thinking of making a mobile app yet. Uh, it's just gonna be a React application, a React front end that I'm gonna deploy on something like, I don't know, Netlify, Vercel, AWS, GitHub Pages, wherever I can. Okay, that's not really that big of a deal. But yeah, overall, this is the architecture. So yeah, thank you for watching. This has been a long video, and I hope those who have been sticking around, you know, maybe got something out of this video. And if not, maybe you just, had fun spending time listening to me yapping about a project. But yeah, thank you for watching, and I will catch you guys soon.